Hello everyone, welcome to today's video. Today, according to the problem description, we have to determine the displacement at point C by using the method of virtual work. EI and EA and GA value is assumed to be constant for all the members, and we need to account when we solve using the method of virtual work for bending, axial, and shear actions on the beam. So without any further ado, let's continue to describe the way how to solve this problem using the method of virtual work. Alright, so here we have the real case for which we have to solve. As it can be seen from the figure, we have a pin support here and a roller support, so basically the structure is going to be statically determinate. Therefore, we are going to have three unknowns and three equations to solve for. So the first step to be done is to find the support reactions on this beam. And by utilizing the equilibrium equations, we can easily do that. If we take, for example, sum of bending moments at point B, we can find the value of support reaction on the vertical direction at point A. Then we can do the same thing for forces on Y. We can sum them up as we already now found the value of AY. Now we can find the other support reaction BY as shown here. While as component reaction AX, this is going to be 0 as there is no lateral load acting on this beam. Next, what we need to do is to find the functions for this beam on those places where do we have discontinuities. And as it's asking from the problem to take into account shear, bending, and axial actions, we have to again just do the sum of forces on X and Y and take the sum of bending moments at the cut. So we decide to have this cut from this direction at distance x, and then we just do sum of forces on x, and we get that for the first discontinuity, and 0 is going to be 0. Then we do the same thing for the forces on y to determine the effect of shear, which is going to be as follows. Then the same thing we are going to apply for the bending moment. Next, let's continue with the other discontinuity, where I decided to take the cut section from the end side, and as same as before, we are just going to take sum of forces on x and y and take the bending moment at the cut to determine the following components as we have them here. Next, let's continue to the virtual beam, and as from the task, it's requiring us to find the displacement at point C. Therefore, we have to apply a unit load at this location. And as previously, now we just have to solve the structure by finding the support reactions, by utilizing the equilibrium equations, and again we just take sum of bending moments at point B to determine the value of reaction AY for the virtual beam, of course. Then we do sum of forces on Y to determine the value of BY as shown here, and for the horizontal support reaction is going to be 0 as there is no horizontal load acting on the beam itself. Same principle applies here for the virtual beam, for which we have to find the bending moment at the location where do we have discontinuities on the beam. And I decided to take the first cut from this side and define these force component functions. Same thing for the other discontinuity. We found the functions for these components. And what's left to be done now is for us to apply the virtual work in order for us to define the displacement at point C. I denoted this displacement with delta C, and what we need to do is that we need to put over the integral all the components for which it is asked to take into account, which is bending moment, axial, and shear forces. So the next thing to be done is just to apply the bending moments which we already found as shown here, and as far as for this axial action, it's going to be 0 as there is no horizontal load acting on the beam as mentioned previously. Therefore, we continue just to add the shear functions, and in the end we are going to have that displacement at point C is going to be as shown here on this part. One good thing about this one is that if the structure is going to be in the same way as it was provided at the beginning, and now we can solve parametrically this type of beam if we are going to use it in the future somehow. Next, let's assume some values, and then we're going to compare the results with the software. And let's assume that the distance is going to be 5 meters. So we have the distributed load 5 kilonewton meters, and the cross section is going to be a square cross section 200 by 210 millimeter thick. And I get this data from the software, but of course, someone if wants to take them, they can visit any website which has this data. And if we insert the following data in the above displacement which we already got, then the value is going to be around 160 millimeters. Just to make sure that what we did by hand calculation is correct, I modeled the question on a finite element method software, and as you can see here, we are going to have the displacement at point C is going to be 160 millimeters, which is going to be the correct one from what we get by hand. So this concludes the video for today. I really hope you enjoyed today's video. If there is any questions, please leave them down in the comment section below. Thank you very much. See you on the next video.